Okay, welcome everybody. Welcome to the NASA Earthdata webinar, Discover Simplified SAR Solutions at the NASA Alaska Satellite Facility Distributed Active Archive Center, or ASF DAAC. This is your host, Jennifer Brennan. While everybody is logging in, we'd appreciate your feedback on the two optional polls at the bottom and middle portion of the page. I see many of you have already responded, so thank you. It is 2 p.m. Eastern Time, so we're going to go ahead and get started. First, I'd like to begin by going over a few housekeeping items related to this webinar. The first thing is to ensure best audio experience, and given the large number of attendees, the conference has been placed in silent mode. If you have any issues or any questions, what you should do is enter them into the Q&A pod located on the lower right-hand corner of your screen. This works like a chat. The webinar will be recorded and posted not only to our NASA online Adobe Connect event catalog, as well as to our NASA Earthdata YouTube channel within a few days of completion. And I do plan to provide those URLs to you at the end. The webinar itself is 1 hour long. We've allocated 45 minutes to the presentation and live demonstration, with another 15 minutes for the Q&A period. After the speaker has finished her presentation, we will then move to the final set of polling questions. As I mentioned earlier, you will have an opportunity to ask your questions by using the Q&A pod throughout. Due to the large number of attendees, however, questions will not be answered using the raising hand function. It has been disabled. What we'll do is we'll take all questions using the Q&A pod at the end. I'd like to now move to our agenda for today. For the first 10 minutes or so, our speaker will provide a brief introduction to and history of the NASA Alaska Satellite Facility DAAC. We will then transition to a tour of the ASF website and a live demonstration for Vertex, a SAR data discovery and access tool. It is my pleasure to introduce our speaker today, Rebecca Miller, who is a science consultant at the NASA ASF DAAC. Rebecca?
Thanks, Jennifer. As Jennifer said, I'm Rebecca Miller, and I'm part of the user support group at the Alaska Satellite Facility, or ASF. I have worked at ASF since 2006, and I've been working in the geophysical sciences field since 2004. In my position, I work with both new and long-standing data users and help make sure they can access synthetic aperture radar, or SAR data. I also maintain and update the social media site for ASF and manage the daily activity of a non-DAAC Geodata Center for the Geophysical Institute. A little background on ASF. In 1978, discussions were started between NASA, the Jet Propulsion Laboratory, and the University of Alaska Fairbanks to establish a receiving ground station in Alaska for polar orbiting satellites. Because of the geographic location of Alaska, and specifically the Geophysical Institute at the University of Alaska Fairbanks, it seemed an ideal place to see the satellites multiple times each day. The Geophysical Institute, with a position of nearly 65 degrees north, made the proposed location ideal to see polar orbiting satellites, up to 10 times per day. Fairbanks is also the most northern urban area in the U.S. and the most northern city with the university, which made it a viable location for a ground station. By 1988, the idea of building a ground station came to fruition. NASA began the necessary steps to reinforce the structure of the Geophysical Institute so it could support the weight of our first 10-meter antenna. Construction was started and completed in the late 1980s. By August of 1991, the first ERS-1 acquisition was downlinked at Fairbanks, and the Alaska SAR facility was born. This SAR image, acquired over Point Barrow, Alaska, is one of the oldest ERS-1 images in the ASF archive and represents the start of ASF's long history of archiving data for distribution for NASA. In 2004, the name changed from the Alaska SAR facility to the Alaska Satellite Facility, as the organization was asked to downlink satellite data for missions that were not SAR. ASF continues to provide downlink services to NASA, as well as other agencies and groups. ASF now has 3 antennas on location at the University of Alaska that are operated on behalf of NASA. AS1 is an 11-meter S&X band antenna installed in 1995. AS2 is a 10-meter S&X band antenna installed in 1988. It was also our very first antenna. And AS3 was an 11-meter S&X band antenna installed in 2013. ASF has been downlinking data for 24 years, and the SAR archive continues to grow with nearly 2 petabytes of data currently available for download and distribution. Simply put, the ASF mission is to make SAR data available. ASF has been providing data for 24 years, and we're always looking for ways to make the data more accessible. ASF is more than just a data center. We offer basic SAR processing and advanced SAR processing. We also develop software tools and data access tools. The Alaska Satellite Facility manages the ASF SAR DAAC. It is one of 12 NASA Distributed Active Archive Centers, the DAAC. The ASF SAR DAAC specializes in radar data collection, processing, archiving, and distribution. Our radar archive contains data from 1978 to the present. These data are or have been supplied by radar sensors on many different spaceborne and airborne platforms. Those missions include the European Remote Sensing Satellites 1 and 2, referred to as ERS-1 and ERS-2, both operated by the European Space Agency, and both with a C-band SAR sensor. ERS-1 was an active mission from 1991 to 2000, and ERS-2 was an active mission from 1995 to 2011. RadarSat-1, which also had a C-band SAR sensor, was operated by the Canadian Space Agency and includes data from 1995 to 2008. The Japanese Earth Resources Satellite, or JERS-1, was operated by the Japanese Aerospace Exploration Agency, or JAXA, and had an L-band SAR sensor. It was active from 1992 to 1998. And the Advanced Land Observing Satellite, or ALOS, also operated by JAXA, had an L-band radar sensor and was an active mission from 2006 to 2011. ASF also distributes data from several outstanding airborne SAR missions, all operated by NASA. They include CSAT, which was acquired in 1978, Airborne Synthetic Aperture Radar, or AIRSAR, which was acquired from 1990 to 2004. The Uninhabited Aerial Vehicle Synthetic Aperture Radar, referred to as UAV-SAR, which began in 2008 and is still actively being acquired, and AirMOS, which began in 2013 and is still an active mission. In addition to the platform data, the ASF SAR DAAC distributes data for other NASA-funded projects, such as its Making Earth System Data Records for use in research environments, or MEASURES, and the RadarSat Antarctic Mapping Project, known as RAMP, to name a few. So why would someone want to use SAR data? SAR is a desirable choice for researchers due to its ability to image, or see, in the dark, and see through both clouds and smoke. These are especially useful qualities for imagery when trying to collect data over coastal or tropical regions or other areas that frequently are obscured by natural conditions or hazards. For example, here you can see the eye of Hurricane Erin as it moved through the Atlantic Ocean. In this 2001 SAR image, we are observing the effects of the wind on the surface of the ocean beneath the clouds. SAR allows us to see what we could not see with the naked eye in optical imagery, day or night. There are many research applications for SAR data. Some examples of these applications include glacier monitoring, search and rescue, oil spill monitoring, sea ice research, urban development, and archaeology, to name just a few. Our data user community continues to find new ways to apply SAR to their work and research. The data are versatile and have potential to play an important role in most research applications that require imagery. So how does SAR work? SAR is collected by sending pulses of energy towards its target, in this case Earth, while continuously moving over that target. As the signals reach the surface, they bounce and depending on the geometry of the surface of the Earth, some of the signals return to the radar. The radar is continuously moving in a linear direction while collecting data, thus creating the synthetic aperture. Radar is very similar to the principle of sound wave reflection. If you shout in the direction of a sound-reflecting object, like a rocky canyon or cave, you will hear an echo. If you know the speed of sound in the air, you can then estimate the distance and general direction of the object. The time required for an echo to return can be roughly converted to distance if the speed of sound is known. Radar uses electromagnetic energy pulses in much the same way. The radio frequency energy is transmitted to and reflected from the surface of the Earth. A small portion of the reflected energy returns to the SAR sensor. This returned energy is called an echo, just as it is in sound terminology. Radar sets use the echo to determine the direction and distance of the reflecting object. A SAR sensor is a mostly airborne or spaceborne side-looking radar system which uses the flight path of the airplane or satellite to produce a simulated, extremely large antenna or aperture electronically, and that generates high-resolution remote sensing data. These data are then processed into images. On some platforms, the radar is able to collect data in several different look angles and beam modes. Because of the look angle of the sensor, several types of geometric distortions are often observed. These effects are called foreshortening, layover, and shadow. Foreshortening and layover effects decrease with an increasing look angle. Shadows increase with an increasing look angle. An increasing look angle is when the sensor is looking farther out to the right away from nadir. Now that I've covered some of the basics about SAR, how can we get started using SAR? The best place to find information is on our webpage, www.asf.alaska.edu. When you arrive at the site, you will immediately see a card that says Get SAR Data. We offer options here for an inexperienced user to get information and options for a more experienced user to start accessing the data right away. If you are new to SAR data, the best option is to select the Guide for Newcomers here, which will give you the option to access the Get Started Guide. You will see other options here, including Vertex. Let's see. We will talk about Vertex, which is ASF's data portal, and Vertex is the most comprehensive and easiest way to access data from ASF. I will give you a tour later in this presentation on Vertex. You will also see an option to use the Asf Api, which is an application programming interface that gives users the option to use command line search and download. Users are given the option to use Ursa, which is another great way to access data and a good way to find Insar stack information for an experienced user. ASF also encourages people to go directly to the Rtc product page where you can learn more about the new products, and access to Sentinel A1 data over the Nepal area is also made easy from this page. Let's talk more about how someone can start using SAR data from ASF. There are several steps users will need to take to access the data, but the most important one is to create an Earthdata login account. Let me get rid of this. Once you've created this account, you will have access to the most data from ASF. Additionally, these are the same login credentials you will need to access data from any other DAAC. If you're already using data from another DAAC, you can skip this step. If you're not ready to download data, that's okay too. Anyone can search for data at ASF. The Earthdata login is only required to download and work with the data and tools. Other valuable information can be found in the Get Started Guide, including basic information about SAR, how users can visualize the data, and access to guides and tools. I'd now like to take you on a tour of the ASF website to show you fast ways to access the data and information you're looking for, and to show you some new features in Vertex. Let's move to the live demo. So welcome to the ASF website. I'd like to take you through some of the key features available on our site and show you how to access frequently looked for information. As a new or experienced user, it's important to know what data are available. A good way to learn about data from ASF is here at the ASF website. Here you can access data, learn about the many data products we offer, find tools to help you work with the data, learn the basics of working with SAR data, and much more. We offer solutions for the experienced user and the beginner. Let's take a look at the cards on the home page. On the far left, there's an image gallery for those people who are interested to see how researchers are using SAR data in their work. Our most recent addition to the image gallery is this interferogram from the September 16, 2015 Chilean earthquake. This one was made using Sentinel data. As you scroll through these images, you can see how researchers have used the data in their work. We have another card here that takes you to pages with information on the ASF satellite tracking ground station. Here you can learn about the station mask, or the range of view for the ASF antennas, the operational details of the 3 antennas on the UAF campus, the milestones for the ground station, and current and past missions. We'll skip over here to the Maps and Photos card, which brings attention to the Geophysical Institute's Geodata Center, which is operated by ASF. And finally, the Explore Highlights card, which brings attention to the newest information, data, and services provided by ASF. Today, I'd like to focus our attention on the Get SAR data card that appears in the center when you first arrive at the ASF homepage, and more specifically, the at-a-glance guide to accessing datasets. To get there from the ASF homepage, select the Get Started Guide for Newcomers here in the center, or at the top menu, you can go to Get Data, and then Get Started right here. The Get Started page puts useful information before users in an easy-to-access format and in a logical order. The page goes over some basic terminology and information about SAR. We also remind users here that they'll need to get an Earthdata login account if they have not done so already. Further down the page, we remind people how to access useful tools to view the data, and that's too far. And the guide also provides links to 3 guides frequently requested or searched for from the ASF website. A main attraction on this site is the How to Get SAR data, accessible in the bulleted list here in the center, or the button at the top right of the page that says Go directly to the at-a-glance guide to accessing datasets. Of course, you can scroll directly here too. Once a user makes their selection or gets to this section of the website, they'll find a comprehensive list of data distributed by the Alaska Satellite Facility. The list is broken down by dataset name, and from there, additional information is given on the best interface to access the data and whether or not proposal is required to access the data. Currently, a simple proposal is required for access to ERS-1, ERS-2, JURS, and RadarSat data. In the at-a-glance list, you'll see that most of our data have an open access policy and are available for immediate download. A useful feature of the list is the ability to click on a product name, which will take you to the product page where you can learn more about the specific product or simply start loading the data. For example, if you click on the AOS-1 PALSAR, you are taken to the ASF PALSAR products page. Here, users can learn about the mission at the About PALSAR link, and when you arrive on the page, you will see a list of the different products available, including the level 1.0 unprocessed or raw data, level 1.5 processed to an image data, and the new RTC products, which I will cover more in depth later on in the presentation. presentation. We'll go back. But if I wanted one of these products, before I go back, you can simply start downloading the data from this access column here. And these features are available for all of our data product pages if you wanted to access the data. Back on this Pulsar page, you'll find more ways to begin downloading data. You can also find useful documentation and access to tools to use with the Pulsar products, and you can gain easy access to the new RTC products again. Let me show you how easy it is to search for and download data. There are a few ways to access the search interface. Again, here in the center of the page, you can go to Get Data Always here. We also offer the option to download data here. And my favorite way is this link on the right, which is on every single page of the ASF website that says Get SAR Data. When you click on this link, you're given the option to use Vertex or the Asf API. We're going to go ahead and move into Vertex and start a demonstration of that. When you arrive in the Vertex data portal, you will immediately see a map to start your geographic search. If you're a new user, you may find this link at the top helpful. Map Help gives you the step-by-step instructions for how to perform your search. I'll go through these steps quickly with you now, and then we'll perform a live search. You can see that you can click and drag to figure out where you want to search. You then click on the area and drag your mouse until you're done, and then click again. Once your area is defined, you can click anywhere in that bounding box, and you'll get points so you can start manipulating your shape. So you can make it as specific as you want. There is no limit to the number of points you can have in your geographic search area. We're going to go ahead and hide Map Help now and do this live. So I like to search for Alaska because I know exactly where I'm going to find data. So I'm going to move my map to Alaska here. I want to search in the Fairbanks area, so I'm going to use my plus or minus areas buttons here in the upper left corner to zoom in. You can continue to manipulate the map to make it so your search area stays within your window. Now that I can see Fairbanks pretty clearly, I'm going to click here on the map and simply drag my cursor until I'm done with the area and click again. I'd like to zoom in a little more, so I'll come back to my plus button here. And now scroll down one more time. So I'm not happy with a rectangle shape for my search area because I'm really interested in is this river, which is the Tanana River. So I'll click in this search area and I'll start to begin to manipulate my search results area, my bounding box here. You can see it's fairly simple. And as I continue to manipulate this, I get more options for more points to continue to change my search area. That's enough for this purpose of the demonstration. Now I'm going to search my date range. The search automatically defaults to the last 2 years from today's date. Because I'm searching for Pulsar data, I know I want my search to be during the time the sensor was active, which was 2006 to 2011. For the sake of the presentation, I'm going to make the time period I search for today very short. So I will come here, and I'm going to select 2008, September 1st, and it'll end in 2008 as well. And we'll go ahead and push it through to December 31st, so we get a few months worth of data. The selection of a platform is very simple as well. When you go to look for platforms, you will notice that they are all selected. This is useful if you're looking for any data over the area of your interest. But because I know I want to find Pulsar data only, I'm going to first click None to deselect all of the different platforms that are available, and then come over and just select Pulsar. Because I'm not selecting any particular granule, I'm going to skip the granule list and begin my search. The search results can take any amount of time, and it's dependent on how large your search area is, how many platforms you're searching for, and the date range of your search. Hopefully this search will give us results fairly quickly, as it's a fairly small area and short time span. Sometimes it takes longer than we'd like. You can continue to change your search if you're wanting to do that as well. You could continue to manipulate this, and it shouldn't affect your search results. It'll just change the area that it's searching for. Probably just a few more seconds. I apologize for the delay. While we're waiting for this, I can tell you that what I expect to happen is that once my search results populate in the column on the right, I will also get a reminder box that opens telling me about the EULA, or the End User License Agreement we have with JAXA. The EULA is a simple agreement, and it only needs to be completed once to have access to download any of the PALSAR data in the data pool. The reminder asks you to go and create a user account, or to agree to the terms of the EULA. And then once you've done that, you can close the reminder window and choose to log into Vertex. I am still waiting for my results. I will check my criteria to make sure everything was the way I expected it to be. This should not take too much longer, I hope. There we go. And this is the ALOS PALSAR End User License Agreement I was talking about. You can see that you can view the terms if you're so interested, which are not super interesting. So for the sake of this presentation, I will skip going through this. You can go ahead and register. If you've already agreed to these terms, simply close the reminder window and come up to the login. And now you can log in before you begin your search too. I'm going to go ahead and log in now. And we can continue on. Now that my search is completed, you can see I have several different images. I have 29 search results that touch the area of interest that I've searched for. As you roll over the images over here in the right column, it highlights the granule in your geographic search area, so you can see exactly how much of your geographic area is covered by this image. You can continue to move through this list. This one appears to cover a lot of them, so what I will do is click on it. And now I can look at the image, and these are the different products that are available to download. It's simple to download the products quickly with this arrow on the left of these green buttons, which takes me to a download window. I can download the data. I can also add these products to my download queue, which I could then use to perform a bulk download option to perform at the end of as soon as I've gone through all of the data results, so I could see what else I was interested in. You can also view these products here in the list by simply clicking the arrow here in the search results and viewing the products that are available here. You'll notice that we have the new RTC products here as a high-res version and the low-res version in these search results. So now that I've added, actually I'll add a few more. Now that we've added a few items to my download queue, I'd like to take us back out of this live demo and go over a few other new and existing products and services offered by ASF. Jennifer. ASF is always looking for ways to improve services and improve user interactions with our tools and interfaces. Although I mentioned them briefly earlier, I'd like to go more into detail on these improvements now. I will introduce you to the Rtc products, discuss new ways to search for data, and review new and existing methods to access and work with data. We'll talk about radiometric terrain correction. At the request of our user community, ASF investigated ways to create GIS-ready products that could be used with other optical datasets, specifically Landsat. The data needed to be corrected for the off-nadir distortions as well. The goal of the Rtc project was to remove the topographic effects from ASF standard ALOS PALSAR data products so customers could more easily classify targets. In order to get started, the products needed to be terrain corrected or orthorectified. Terrain correction corrects the geometric distortions that can lead to geolocation errors. Terrain correction moves image pixels into the proper spatial relationship with each other, removing the effects of layover, foreshortening, and shadowing. The product also had to be radiometrically corrected, which involved removing the incidence angle dependency of SAR. The goal of radiometric correction is to avoid radiometric errors or distortions, while the goal of geometric correction is to remove geometric distortions. This step required depicting the calibrated radiometric control sets to be used in certain areas to improve accuracy. Finally, for ease of use, the product type determined to be most useful and most versatile was GeoTIFF, as is widely used in most GIS applications. ASF offers ASF offers two RTC products. A low-resolution product, which is a 30-meter pixel image meant to fuse with Landsat 7 and Landsat 8, and a high-resolution product with native resolution to the instrument. The high-resolution products are either a 6.25-meter pixel or a 12.5-meter pixel image, and all RTC products are in UTM projection. They are plug-and-play products and are available as downloadable products that require no manipulation prior to use. Currently, we have processed about 95% of all fine beam and polarimetric pulsar data in the ASF DAAC data pool and expect to have the project completed early next month. The products in the Rtc product guide can both be found online at the ASF website. Some simplified data access steps we've taken include the new service, the map server. The purpose of the map server is to make SAR data access simplified for those users who use GIS platforms. Map server is an open source platform that allows the ASF user community the ability to connect directly to ASF's archived mosaics through a web mapping service, or WMS. All the data available through the map server are freely available, requiring neither a login or password to access the mosaics. Our website offers step-by-step instructions for users of either QGIS or ArcMap to access the ASF map server. While negotiations between the European Space Agency and NASA are ongoing, the addition of the Sentinel-A1 data to the ASF archive after the April 25, 2015 Nepal earthquake has proven invaluable for researchers and rescue workers alike. New Nepal data continues to be added as it becomes available. There are a few ways ASF has made the Nepal data available from the website. You can search the Vertex data portal. You can choose the Nepal data extras from the website, which takes you to an index of Sentinel data available in various formats, and the data feed, which can be used in either a feed reader or as a raw RSS feed in an RSS-friendly browser. You can access these products from the ASF Sentinel A1 web pages as well. ASF offers two APIs for machine-to-machine access to SAR data. The ASF API searches for data products available at ASF. It helps users construct and test API commands. It also holds a full list of keywords for improved search results. API commands can be incorporated into scripts or used at the command line via the Mac terminal window, PuTTY on Windows or on Linux systems, making it versatile for many users. A new tool offered to ASF users allows direct access to Interferometric SAR or Insar data. It's a result of a collaboration with UNAFCO, a nonprofit university-governed consortium for research and education in the geophysical sciences, Open Topography, an organization who facilitates community access to data, NASA's Jet Propulsion Laboratory, or JPL, and ASF. The goal of the collaboration, called the Seamless Synthetic Aperture Radar Federated Archive, or the Sara Api, was to design and implement a seamless distributed access system for SAR data and derived interferometric data products. Step-by-step instructions are available for new or returning API users. Instructions to show you how to get started, build an API command, search, visualize, and download data, as well as provide a list of keywords and a troubleshooting tab to help you work through common or known issues. The Sara API allows users one-stop access to Insar pairs corresponding 90-meter SRTM digital elevation model (DEM) data and water vapor models from the online services for correcting atmosphere and radar called OSCAR from NASA's JPL, and standardized Insar data products from archives at ASF and UNAVCO. As I showed in the demo, ASF offers a bulk download option for our ASF data pool data users via MetaLink files when you have things in your download queue. This download option increases speed, reliability, and security of data downloads. When working with Vertex, ASF recommends using the Firefox with the download client down them all for the greatest success. If you're already in Vertex with data products in your download queue but do not yet have a download client, don't worry. You can get a download management client while in Urso when viewing your cart here. And all download clients recommended by ASF are free and only take a few minutes to install. Once you've installed it, you can click the bulk download MetaLink button in the bottom of the download queue, which will then give you the option to select down them all and here, and then you can complete your download. Once your download is started, Down them all will open a new window. This window gives you the option, it shows you that completed downloads are displayed as a solid green bar. The number of files, size of the files, and the connection speed will influence the time required to complete all downloads. If a download times out for any reason, you can simply right-click on the progress bar and resume the download when you're ready. A tool that is not new but can't be overlooked is ASF's MapReady. MapReady is a suite of SAR processing tools that accepts level 1 detected SAR data, single-look complex SAR data, and optical data from ASF and some other data facilities. It can terrain correct, geocode, apply polarimetric decompositions to multipole SAR data, and data can be saved to several common imagery formats, including GeoTIFF. Other software included in the package are an image viewer, metadata viewer, a projection coordinate converter, and a variety of command line tools. We offer MapReady for different computer platforms and provide additional resources for using the tool. There are many other tools and services to explore data from ASF. I invite you to take time to visit the website and see how SAR might be useful for you. I hope you feel inspired to learn more about SAR data and to learn how ASF might be able to help you with your research or data requirements. I have a few more slides that contain useful links, but I'd like to now turn it back over to Jennifer.
Okay, thank you, Becca. Thanks, everybody. Just to let you know, we'll go through the useful links really quickly, but this presentation will be available for download, okay? And so you'll be able to take a look at those in further depth later. What we're going to do now is move to our final set of polling questions. I'd like to give these just a couple minutes or so, and after that, we will move directly to the Q&A period. So do be sure to stay on the line and or in the meeting room to participate. Okay, so we'll give these just a couple of minutes, and then we'll move along to the Q&A period. Thanks, everybody. So we're going to give this just another 30 seconds or so, and I do want to thank you. There's some really excellent feedback here for those of you who have decided to answer the polls, and that's really helpful as we're determining future topics and future webinars. So thanks very much. Okay, everybody, we are now going to move directly to the Q&A period. And just a couple of notes before we get started. First is, I did notice a few questions or comments earlier whether or not these presentations would be available for download later. And the answer is yes. If you look in the lower right-hand corner of your screen, you would select the presentation, and then you'll be prompted to download the file. So you would highlight it by left-clicking on the presentation. You'll be prompted to download. This will also be a persistent feature were you to check out the webinar recording, which will be posted to our online catalog, as you can see on the slide over here to the left. If you were to go to the tinyurl.com Earthdata webinar, I do actually have all of our webinars from the end of May 2013. We've got I think at the end of this month, there'll be 46 data access and discovery webinars for you if you're interested. And certainly you'd be able to still, click at the end of the webinar and download the files. In addition to that, they will be posted to our NASA Earthdata YouTube channel. If you search NASA Earthdata on YouTube, you will find the webinar. Probably that'll take me a couple of days, so certainly by the beginning of next week, if not by Friday, close of business. All right. So why don't we now jump to the first question, which was asked actually pretty early on. And not only do we have Becca in the room, but we also have Dr. Franz Meyer. Is that correct? For answering questions today.
Yes, I'm here.
Okay, wonderful. So thank you. And the first question was asked by one of your users, and it's really more of a comment, but also a question. I have got in the past pulsar data 1, I believe this is accurate, please correct me, participant, if I'm not, for my region, but when I checked ASF database, all of the data was not the same, especially data for 2010. Is it true that the database is not totally complete? Either one of you care to answer, Franz or Becca?
So I would say so my immediate reaction would be that over the Americas, over North and South America, the database should be complete. So ASF was the America's ALOS data node and received all the data sets over North and South America, plus pieces of the Antarctic Peninsula and some pieces of Greenland. If your area of interest is outside of this area, we are likely to have data sets for you, but possibly not all of them. Outside of our main area of responsibility, we do have data sets if users requested them throughout the lifetime of the mission. But we may not have all data sets that are available. But I would think and I would hope that if the area of interest is within North and South America, we should have the complete archive. Should that not be the case for you, whoever asked this question, please contact user services here at ASF, and we'll investigate and make sure that we have all of this data sets for you and can deliver those to you.
Okay, and Mohammed, I can actually send you, if you're not familiar, the email link for user services offline. And then I wanted to make one other quick comment. For those of you who might be interested in receiving announcements for upcoming webinars, there is a link on our Earthdata, our tiny URL, Earthdata webinar site where you can subscribe to only receive announcements. There's no other information coming through that listserv. And now let's move to the second question. The second question is ASF planning on hosting, distributing ALOS 2 data?
So ASF is not a ground station for ALOS 2 data, so we will not be hosting and or distributing ALOS 2 data sets. So these data sets you would directly order from JAXA. So I tried that actually yesterday. If you just Google for ALOS 2 radar data sets or so, you get to the main JAXA page, which now actually is much nicer and does provide you links to where data sets can be searched and downloaded. Also, if you're interested in that, watch out for regular announcements of opportunities. ALOS 2 data is not free usually. It's sold commercially, but regularly they have announcements for PI proposals. Unfortunately, the last PI proposal deadline was last week, but there's a new one coming up, and through very simple proposal processes, you can get free access to a low number of data sets, about 50 per year per PI.
Okay, great. Thank you, Franz. The next question is, I assume that this user will actually ask the question. He had asked whether or not there was room for submitting questions about SAR processing, for example, stacking and trade processing. So I will hold for that question. The next question is, can you recommend a good open source software for processing Insar data?
Yes, so for processing Insar data sets, there are a series of open source processes that you can use. Let me think which. So there is, for the data sets that we are holding, good processing systems would be the processing system ICE, and that's spelled ICSE, C as in Charlie, SE. That's a system that is developed by JPL in collaboration with Caltech and Stanford University, and is available through UNAFCO or by just Googling for ICSE SAR, for instance. You will get to the download page. It requires a little bit of reading up initially to know how to use it, but that's a free software package for SAR processing and basic Insar processing. On top of that, there's a second tool that can be used for stacking. If somebody's interested in more sophisticated Insar processing, this toolbox is called GIANT, and it's spelled as you would think, GIANT, and it stands for Generic Insar Processing Tool or so. I actually have to look that up. But again, if you Google for GIANT Insar, this is a free time series analysis type or stacking type Insar processing system. Other tools, and we can probably, maybe, I'm not sure if we can send an email out to the attendees. We can list them all. Another tool is GMT-SAR, which was developed by Scripps University, and there are a few additional ones that we could recommend.
Sure, I can absolutely do that. If you email me separately offline with this information, I will send the useful resources that were mentioned during this discussion to not only those who attended, but also those who registered but were unable to attend. Absolutely. Okay, moving on to the next. This is more of a comment, and just to comment, the ALOS 2 proposal deadline is extended until this Friday.
Oh,
that's
excellent.
An FYI for everybody. And yes, and then one of our participants has asked whether or not you would mind sharing the link for the ALOS 2 PI opportunities, and I think that could certainly be part of what you can email to me.
Absolutely.
That would be fantastic.
Right, and while it sounds close that it's Friday, it's a very simple proposal, so you should still be able to get a proposal in.
Okay, great. Thank you. The next question is, I've processed NVSAT and ALOS PALSAR data using, it's more of a comment, pardon me, using GMT-SAR. And the person who is speaking now is Dr. Franz Meyer. Did you want to say a few words about yourself, Franz, so people can have the context as to how you fit in with ASF?
Yeah, so my name is Franz Meyer. I'm here. I'm a associate professor at the University of Alaska Fairbanks for radar remote sensing, and I'm also the current chief scientist of ASF. So I'm working in both the theory of Sar and Insar, but also its applications to earth science questions.
Okay, wonderful. Thank you. Our next question is, any plans for collaboration with RadarSat-2 and RadarSat Constellation programs?
Yes, there are always plans for collaboration. RadarSat-2 is a commercial, so the way RadarSat-2 and RadarSat Constellation are operated is slightly different. RadarSat-2 is mostly a commercial mission, and so getting access to data sets is a little bit more difficult. There are also PI proposal opportunities for RadarSat-2. The problematic part of this is if you are a US researcher, you have to find either a European or a Canadian PI to work with. There's really not that many opportunities for US researchers for the submission of PI proposals, and you would have to collaborate with a colleague in Canada or Europe. Constellation, Mike, and I will have to verify that what I'm saying is true, but the way Constellation is being operated is going to be different. The data set is going to be less commercial. I'm not sure if it's entirely non-commercial, but it's going to be less commercial. So opportunities to access and get data sets are larger. Whether or not ASF is going to be collaborating with the RadarSat Constellation mission is not clear to me at this point. But for the community, I think there's going to be a broader opportunity to get data sets from that mission or from that constellation of satellites.
Okay, and just a quick point of clarification. Earlier I had incorrectly captured the acronym for one of the software packages. It is ISCE, and I had incorrectly captured. So my apologies, but just repeating the note that I will send a list of resources for those software packages that were mentioned during the discussion to all registrants and participants. So thank you for the correction. I appreciate it. And our next question here is, okay, so line of sight results and unwrapped interferograms showed deformation where there isn't any. I assume that such deformation is a result of atmospheric effects. What do you recommend for the removal of atmospheric effect? Have you used TRAIN?
I have not yet used TRAIN. I know of the package. I think it provides various options for atmospheric correction. So typically, in the end, there's really two sources of atmosphere-related signals that you typically see in interferograms. One comes basically from the distribution of water vapor. And if you look at an area that is not supposed to be deforming and you see structures that are kind of cloud-like and cloud-shaped, wobbly kind of phase screens, this is typically caused by sort of the turbulent distribution of water vapor in the atmosphere. A second component typically comes from, can be seen in areas where there's topography, and it looks like a residual topography signal. And that is caused by differences in the overall vertical refractive profile of the atmosphere at the two acquisition dates. So these are the main two pieces. The one that correlates with topography can usually be easier removed, either using atmospheric models. Sometimes only a few GPS stations at different altitudes allow you to extrapolate or calculate sort of this refractive profile difference and remove it. The turbulent component is harder to remove. Atmospheric models usually are not good enough to capture those. Sometimes you're lucky and you may have an acquisition of the electro-optical systems MODIS, or for instance MODIS right now if you have a recent data set. If you get a cloud-free MODIS acquisition close by or close to the acquisition time of your SAR data set, you might be able to use MODIS for correction. But I think the train package is a good place to start from and experiment basically with the various options that are provided. If you have more data sets, you also can try stacking. So one of the reasons for doing stacking where you use many interferograms instead of one is to apply some filtering and remove phase screens through filtering processes.
Okay, thank you, Dr. Meyer. Our next question is, any applications to monitor transportation infrastructure movements, for example, bridges, roads, railways, etc.?
Yes, so the data sets that we are currently holding at ASF have not been applied much to looking at bridges and roadways. However, the higher resolution X-band data sets, as they may be provided by systems like TerraSAR or Cosmos SkyMet, those are used for transportation infrastructure monitoring now in at least pilot projects. There's a pilot project with the Virginia DOT where Cosmos SkyMet and TerraSAR X data sets are used to try to understand the health of road surfaces and try to map the motion of bridges. It's in an experimental state, in a research state in this case, but we are at this stage right now, but we are finding parameters that can be derived, and we're studying these things actively. So there's at least one project going on. There are several smaller projects for bridge monitoring going on also at various universities. So people are trying to develop tools and applications in that field.
Okay, thank you for that response. And I do want to add really quickly for everybody, the questions and answers that have been addressed here, the log for those files will be sent to both Franz and Becca, so there is opportunity to follow up offline if need be for any of these. So I will put you in contact with one another. The next question is, what do you offer for L-band atmospheric correction, both for ionospheric and tropospheric correction? Is a package available for ISCE or ROI_PAC for this aim? You have some publications regarding this topic. Would you please guide us briefly?
So for atmospheric correction, there are not many of these packages yet that provide methods for atmospheric ionospheric correction. ICE does include, I think, at least in the development version, does include an approach using Faraday rotation for correcting for ionospheric effects. We are actively right now working with JPL in including split spectrum methods for correcting for interferometric phase screens caused by the ionosphere. So there's development going on in that direction. And then there's an atmospheric a package for atmospheric correction, a public domain package that was just released. I think that's the train package, and I can send a link to where this package can be found in an email. So when we send out a follow-up email, we'll include some information on that. So it's being developed more and more, and but currently there is not a lot of tools out there that are ready to be used. But it's at least for the ionosphere. For a troposphere, there are some tools out there that can be used, and we'll summarize those in an email.
Okay, thank you. The initial Q&A period, it's 3 o'clock now, and so we will extend it an additional 15 minutes just to 3:15 p.m. So any questions that are not answered within that time frame can be addressed offline with Dr. Meyer and or Rebecca Miller at ASF. So our next question is, can you offer pre-processing for ERS 1 and 2 data?
Pre-processing meaning probably refers to focusing or SLC production, I'm assuming, or I'm guessing that's where the question is going. We don't have a process in place that would allow us to respond to a large number of users for pre-processing. We have done that occasionally for one or the other user, but I don't necessarily want to say to this group that we are we are doing this on a larger scale. I think I would refer users to one of the software packages that are available, like ICE or ROIPAC or GMT-SAR for focusing of the SAR images. And so the reason for the question is probably because ASF is providing ERS data only in raw, unfocused formats and not as SOCs. But again, we can follow up with links to the software packages that can be used for focusing. We can also, I will put in a link to the UNAFCO database. UNAFCO has a good database of ERS1 and 2 datasets that are focused to SOCs and can be downloaded once one becomes a UNAFCO member. So I can provide that link as well.
Okay, wonderful. Thank you. The next question is, have you done processing with GMT-SAR? If so, what threshold values do you recommend for unwrapping via snafu and geocoding?
So I personally have not worked with GMT-SAR. I know a couple of my students have, so I can't give you a really good answer to that question. What I would recommend is to contact the GMT-SAR folks at Scripps Institute in San Diego. There are regular training courses for GMT-SAR, one of which was held in August, and they might be willing to provide all the training documentation to you on request. And otherwise, they're usually very helpful folks, so they can answer those questions probably better than I can.
Okay, wonderful. The next question is there an open source package available for bistatic interferometry?
I don't think so. I would be surprised. I don't think there is. I know that if you order data sets from the German Aerospace Center that were acquired in bistatic imaging mode, you can order them as pre-processed, co-registered SOCs for interferometry that then can be used in a regular Insar processor as usual. I do not think, but I don't know for sure whether there is a public package or an open source package available for that. I can investigate and try to find out.
Okay, thank you. Let's see. I'm waiting for some clarification from an earlier question asking for references. I want to make sure I understand references are with respect to the earlier question. So we'll hold on that for a moment. The next question is there any PALSAR data available for use in agriculture in South American countries like Colombia?
Yes, South America. So we should hold all the PALSAR data sets, PALSAR 1 data sets over South America. So if you log into Vertex, as Rebecca had showed you earlier, you should find a good number of data sets over Colombia. I don't know exactly what the temporal sampling is, but there should be a good number of data sets available.
Okay, thank you, Dr. Meyer. The next is more so a comment. Comment for the last question regarding the GMT-SAR. All the GMT-SAR material from the short courses is available from the UNAVCO website.
Excellent, yep, that's true.
Okay. Okay, so one of our users has asked, can you provide references? And he is referring to references at the Virginia DOT regarding road and bridge monitoring. So could you possibly include any of those citations, for example, in the resource list?
Yes, I can. Yes, I can find some references. There's also going to be, we'll actually have a workshop, a half-day workshop at the upcoming TRB meeting, the Transportation Research Board meeting, that's going to be held in January in Washington, D.C. We'll have a half-day Insar for transportation monitoring training session. So there will be material available through that. And in addition to that, I can find references from the project and forward those to you guys.
Okay, great. Are there any further questions from anybody? I'll give it just a second here. Okay.
One thing I wanted to say before everybody leaves, if I can real quick. There will be a workshop. There's a workshop coming up in mid-October, I think from the 13th to the 16th of October. And it's the NISAR applications workshop. NISAR is the upcoming NASA L-band SAR mission that's going to be launched in 2020. And there is a workshop in Ames, in California, where we try to meet with the applications community like you folks and solicit input for the mission. I will include a link to the workshop information. So if you still want to attend this workshop, you can contact, I will provide a contact information. You can try to still get in. Officially, the workshop is, registration is closed already, but you can still contact the main organizer of the workshop and get a late approval to be part of it. I think it might be useful for some of the applications communities to attend.
Okay, thank you. And in that vein, could you also include information for the workshop that you have referenced for January? I think we do have a participant at the moment who would like to be included in the distribution list. So if that could be, a link that I send out in addition to the others, I think that would be valuable.
Yes, I can do that.
Okay, great. The next question is there any advance on estimation of biomass and yield crop using SAR data?
Yes, so there have been some success with using amplitude data and correlating amplitude data with biomass. And I'm not sure how to define progress. There are papers out there that say it succeeds with a limited amount of training data sets if one utilizes the correlation between amplitude, the brightness of the SAR image, and the amount of biomass. It succeeds better if you have cross-polarized data sets than for co-polarized data sets. There are also attempts of using coherence for biomass estimation and phase. So I'd say it's the most operational one of those approaches is probably the amplitude approach. The coherence approach is more difficult if data sets were not acquired at the same time. So it's a broad research field. I think there is progress, but I don't think there is a solution available that works broadly for all kinds of forests. That's as much as I can say to that. Hope there might be somebody on the email list that works in that field and can provide more information.
Okay, thank you. I'm just looking to see if there are any other. Does anybody else have any questions? There's still about 5 minutes remaining for the extended Q&A period. I'll give it just a minute here. If I don't see any further questions, what we generally do is I will leave the online meeting room open for an additional 10 minutes, but we will log off from the telecon, so there will no longer be any audio. But certainly if you think of any questions, again, as I said earlier, the Q&A transcript or log of the questions that were asked during this webinar will be forwarded along to not only Dr. Meyer, but also to Rebecca Miller at ASF DAAC. Okay, are there any further questions? Give it a few. And I do want to thank everybody for joining us today. We actually do have a webinar coming up next Tuesday, and it's not focused on SAR data, but it is focused on how using OpenDAP as a solution for accessing NASA Earth Science data. And we will have 3 different instances featured. The 3 will include an instance from our Land Processes DAAC in Sioux Falls, South Dakota, our Langley Atmospheric Science Data Center DAAC in Hampton, Virginia, and then finally our Oak Ridge National Laboratory DAAC, the Threads data server in Oak Ridge, Tennessee. So thanks everybody very much for joining us. Again, I will leave the virtual space open for an additional 10 minutes. If there's nothing else, we will log off from the telecon. And thank you, Dr. Meyer, and thank you, Rebecca, for your presentation today.
Thank you.
All right, thanks everybody. We are going to log off the telecon at this point in time. Bye-bye now.